Okay, so in this lesson, we're going to be looking at properties of logarithms. So the properties of logarithms are very similar to your properties of exponents. So exponential and logarithmic functions, which we've been talking about, undo each other because they are inverses. Log properties and exponent properties or laws share some similarities because of their relationship. So if you remember when we were dealing with laws of exponents or properties of exponents, if the bases are the same and we're multiplying, then we add the exponents. Very similar to log. If you have a log base b of m times n, that is the same thing as breaking it up and expanding it into taking the log of the base m plus the log base b of n. So again, very similar to your exponent rules. Quotient, which is dividing. So if you remember, if bases are the same and we're dividing, we subtract the exponents. Very similar on logs. If I have a log, I can rewrite it and expand it by taking the numerator, so log base b of m, and then subtracting log base b of n, the denominator. The power property, if you remember, when we have a power raised to a power, we multiply the powers. So if I have a power on a logarithm, then what I can do is multiply it and bring it in front and make it a coefficient. So you're doing n times log base b of m is the same thing. So we're going to be using those properties in order to expand and then condense. So expand means write it into multiple logs. Condense it means condense it into one logarithm. Okay, looking at the first one. So notice we are taking the log base 8 and we're dividing these. So we can write this as log base 8 of the numerator x. When you divide, you subtract. So log base 8 of 3. So those mean the same thing. They're equal. Okay, so looking at part B. Notice I'm multiplying 5 times x. And then also I have an exponent. So when I multiply, I can add the logs. Log base 2 of 5. I need to split it up because I'm doing 5 times x squared. So plus, and then I'm going to go ahead and bring my exponent in front and multiply it. 2 times the log base 2 of x. So those mean the same exact thing. So split it up when you're multiplying by adding. And then if you have an exponent, multiply it in the very front of that log term. Make sure your bases never change. So your base you should just carry along. Okay, next one. Notice in the numerator here that we're multiplying 2 times x squared and then we're dividing by 7. So I first want to split up the numerator. So natural log of 2 plus natural log of x squared, but I'm going to go ahead and put the 2 in front, 2 times the natural log of x. And then I have to subtract the denominator, so natural log of 7. So when it says expand, you're breaking it up and expanding it into multiple logs based on the properties. Okay, so now we're going to do the opposite. Now we're going to condense, which we're going to be using this in order to solve log equations. So condense means write it as one logarithm. So notice all of these logs have the same base. It's all a common log, which is base 10. So the first thing I notice is I'm adding the first 2, which means I would take 3 and I would times it by x. So 3x. And then I'm subtracting log of 2, which means that needs to be in the denominator. So every logarithm that you are subtracting would go in the denominator. So I condense this into one logarithm. So using those properties that we just talked about. Okay, so looking at part B, notice I have 2 times log base 3 of x. So I'm going to go ahead and write that as an exponent. So you're doing the opposite. This becomes a cubed. And I'm adding, so that means I need to condense it by multiplying them. So log base 3. And then I'm going to go ahead, since 5 cubed is a number, 5 times 5 times 5 is 125. And then I'm having to multiply it by x squared. So 125x squared would be my log that I'm taking. Okay. Part C, notice I have 2 times natural log of x. So I'm going to go ahead and make that an exponent. And notice we're subtracting. So to condense this into 1, I look at my first natural log that I'm taking. X squared goes in the numerator, and then since I'm subtracting, whatever you subtract goes in the denominator. A lot of students want to do this. But remember, when it says condense, you only want one log in your answer, whether it be a natural log or a common log or whatever the base may be. So make sure you only write the logarithm once, okay, when you are condensing. All right, let's take a look at the back. So the back, we're going to be using this in order to solve log equations. So remember, we went over that last lesson. And we went over the different ways to do that. So we're going to be using the log properties to condense equations that contain multiple logarithms. So sometimes you have multiple logs in an equation. So what you want to do is you want to move them all to one side and condense them. So you're first going to rewrite with the logs on the same side. So move them all to one side. Then you're going to use the log property to combine the logs and condense it into one. And then you're going to solve the log equation. Remember, you can either change it from log form to exponential form by rewriting, or you can exponentiate, which means that you are raising or taking the base of both sides. Okay, so you can do either way. I'll do both, one on part A and one on part B. So it doesn't really matter how you solve your log equation. Then at the end, you're solving your resulting equation. Make sure that you're checking for extraneous solutions. Remember, I talked about that the other day. Just make sure that you're not taking the log of a negative number. That can't be negative there, okay? Because remember, domain is not all real numbers. Okay, all right, so looking at it, first thing I need to do is look and see if I have all my logs on one side, and notice I do. Also notice the bases are the same, so I'm going to condense them. I'm writing natural log, and since I'm subtracting, I divide it. I take the first term, which is x squared plus 2x, and I divide it by whatever I'm subtracting, which is 3x. So remember, to condense, you write one log, and it equals 4. So two ways of solving. You can either rewrite this as exponential, or you can go ahead and put a base on each side and make both of these exponents. So either way. Okay, so I'm just going to go ahead and put a base on each side. So notice the base of this logarithm is e. So I need to do e raised to the natural log of x squared plus 2x over 3x. And then I also have to do the same thing to the other side. So the reason I did this is because now, since this is the base and my base of this natural log is e, they both cancel. That's the whole reason you are using that base. So they cancel out. You're left with x squared plus 2x over 3x equals natural log of e to the 4th. Okay, so now what I want to do is I'm going to solve for x. Notice my numerator here. I'm going to be able to take out an x here, which is x plus 2. So notice this x is going to cancel with this x, so it makes it a little easier if you simplify it if possible. So now I'm just left with x plus 2 on top over 3 equals e to the 4th. So again, this makes it a little easier. So if you can simplify it by factoring out a GCF and then reducing it, it might make it easier for you. Okay, so now notice I'm going to need to get x by itself. So I first have to multiply by 3. So that would be x plus 2 equals, that's just going to be a 3e to the 4th. And then I need to subtract 2. Remember, e is a number, so I can actually use the calculator to find my actual answer here. So you're doing 3, and then remember your e button. You can either use the second divide or the second natural log. So I'm doing 3e to the 4th power. And then I am subtracting 2, so minus 2. not in the exponent though. So I get a decimal. I'm going to go ahead and round it. So it doesn't say, so we'll just round to 3 decimal places. So 161.794 would be our answer. So we just used a calculator here to evaluate that. So 161.794. Now, remember, you always want to, when you're solving log equations, make sure that it's not going to cause these to be negative numbers in there, and notice it doesn't because they're all positive there. You could also check it by plugging in that decimal that you got in for all the x's there. Okay, let's try another one. So this one, notice I have a log on one side and a log on another. So I'm going to go ahead and move my log to one side. So I'm going to add it. So log base 3 of x minus 6 to both sides. So I'm just moving that whole logarithm to the other side of the equation. So that way they're all on one side. And then my right side now is just that 3 that's still there. So I moved all my logs to one side. Now I can condense it since my bases are the same. So I'm going to write one log, base 3. And then when I'm adding, remember you multiply. So that's going to be x times x minus 6 equals 3. Now, you can go ahead and put a base on both sides if you want to do it that way, or you can rewrite it. So I'll go ahead and use the rewriting method on this one since we did the other method on the last one. So you can pick. I don't really care which way you do it. So you always begin with a base. So 3 to the 3rd power equals x. I'm going to go ahead and multiply x squared minus 6x. Okay, so 3 cubed. Make sure you're doing 3 times 3 times 3. Don't just do 3 times 3 and get 9. It's 27. Notice now you have a quadratic equation that you're going to solve. So I'm going to set it equal to 0. And you can use whatever method you want to solve this quadratic equation. Quadratic formula, factor it, plug it in the calculator, find your x-intercepts. So either way, I'm just going to factor it. So sum is -6, product is -27. So that would be -9 and 3. Once you have factored it completely, to solve it, remember you're setting each one equal to 0. So x would be 9 on that one. And x would be -3. Make sure, remember, at the end when you solve a log equation, make sure it doesn't cause your log that you're taking to be negative. So if you plug in a 9 here, notice that's positive. That would make that positive there. But if you plug in a -3, notice this would be negative and this would be negative. We can't take the log of a negative number. So the -3 answer does not work. So make sure you're checking for those. So just x equals 9 for that solution. Okay, so condensing is used whenever you have multiple logs in your equation. You want to condense it into one so that way you can solve your log equation. If you have any questions, please let me know.